Okay, right. So this is the protocol stack. Okay, for the we have two types of protocol stack. We have one is one protocol stack for control plane and another protocol stack for user plane. Okay, so in generally, right? So for example, from place A to place B, right? If you wanted to travel from place A to place B, right? So road is like this. Let us take, right? Construction of road is hard all the time, right? Construction of construction of road is right, definitely takes time and hard. Right. So once road is constructed, right, easily vehicles can move from A to B or B to A. So here also, whenever this UE wanted to talk to base station or whenever this base station wanted to talk to UE, right, the channel establishment, right, whatever we were discussing about the pipes, right? So pipes construction is hard, right? Pipes construction is not so easy. Once a pipe is constructed, right, anything, right? If you wanted to, for example, there is a canal going, right? Your farm is maybe 500 meters away from the canal. Then you have to, right, get water from the canal to your farm by constructing the pipeline. Definitely, construction of pipeline is not so easy, right? It is costly, it is time consuming. So here also, construction of these things means establishment of bearer, okay, tunnel is right, takes right time, and also it is critical, not so easy. Okay, so means this establishment and signaling comes under control plane. You can say construction, control plane, right? For example, when a road is constructing, right, generally the workers or municipality takes control over that road, right? They will keep a barricades, right? They don't allow anybody until that work finished, right? We know. So similar thing, right? Control plane, then user plane. So control plane protocol stack and user plane protocol stack. User plane, control plane protocol stack, right, establishes the pipes, and user plane stack, right, push the or pump the traffic. Pump the traffic. Pumps the traffic. Okay. Pumps the traffic straight away. Traffic means like packets, you can say. Packets. So we have two types of protocols. So here control plane protocol involves, right, and right in our discussion, even though we discuss core part, but mainly our focus is UE, E node B, G node B, right, MME, end. Okay, other core part is gateway, P gateway, right, PCRF, then you can say UPF, SMF. These are right, we discuss as a part of bearer establishment or session establishment. But core network itself, right? There are IMS core, then core, it is a separate subject. So whatever we cover, right? We cover UE protocol stack, E node B protocol stack, MME protocol stack. Okay, right. So you can see this is my UE, right? We know that these two will communicate with UU protocol stack. So what is the UU protocol stack? Right? So UU protocol stack, simply I can say, if I take control plane, we say CP plane, user plane, UP plane, right? Protocol stack. So here one stack will be there. Here another stack will be there. Okay. So here physical layer, then definitely physical layer. Here also there is a physical. Right. So MAC layer and MAC. Okay. Then RLC layer. RLC. Okay. BDCP layer. BDCP. Okay. So NAS layer, PDCP, then RRC layer. Okay. Here also there is a RRC. Of course, one extra layer is there here, which is NAS layer, right? Non-access strata, where here MME will be there, at MME NAS will be there. Okay. So these two layers will communicate each other, right? So here if I say NAS layer, of course, all other things, right? Physical layer, this is physical layer of our general OSI ISO. Okay, so this is the stack, means like UU stack. So this layer communicates with this layer. 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 This layer will communicate. Means like, see, for example, two managers are there. Right? Definitely, if something is wrong or some issue is there, engineer level, right? People talks engineer level, right? Two departments. Let us take two departments are executing some test case or something they are doing, right? So if one engineer seen some issue, then he discuss with other side of engineer, right? Once engineer talks, then manager will talks, right? So manager level discussion, engineer level discussion, manager level discussion, senior manager, director level, then right, CEO level communication. Always this happens. So here also, right, physical layer can communicate with physical layer only, because whatever the data format here can only understand the data format here. Okay. So data format at here can only understand data format at here. Means like whatever, for example, here it is mobile is in transmission and it is in the receiver. Means whatever the physical data sent from the mobile to the base station, right? That will be understand at the physical layer only, right? If it is bypassed this data, right? If it is straight away given here, then this Mac will in confusion what kind of data it is. It will look like a Chinese language to its Mac link. This layering formats, level to level, so layer to layer communication, or you can say peer to peer communication. Got my point? Hello.
Yeah, yeah.
So
Yes, yes.
always, right? Whatever the message sent by the RRC can only understood by the RRC. But always communication, remember communication, whether, right? Now, let me draw one more, because, right, fundamentals you should understand. Otherwise, you will never understand the topics. Okay. So, for example, so here this is my UE and this is my base station. For example, my base station is sending one RRC message. Let us take this is sending a RRC message. Right, RRC message never goes like this. What is the meaning of this dotted lines? Dotted lines, right? Understanding level. This is understanding level, message understanding level, I can say message understanding level. But whenever my RRC wanted to send a message, right, this will right, transfer to next layer, next layer, next layer, next layer, next layer, right? This will be received right from the physical layer, right, this forward to the next layer, the next layer, next layer, right? Finally, it will be read at RRC, right? All these does their job, right? Physical layer does its job, right? MAC layer, RLC, EDCP. Finally, right here, message construction or maybe message construction or message formation happens here, right? Message read happens here. Okay, means RRs. So who sent the message? RRs. Who read the message? These are all right intermediate layers which will help the data or which will help the message from to move from one end to end. Right? Message is constructed here that will be forwarded to the lower layer. Always, always. Right? If it is a sender, right? It is the receiver. From the sender or you can say transmitter, right? Communication moves from higher layer to lower layer. Okay. Where at the receiver? This is at the receiver. Okay. At the receiver. Okay. Communication. This is the rule. Communication moves from lower layer to higher. This is what we say protocol, right? It's a rule, right? Always message has to move from higher layer to lower layer in transmitter, whereas in the receiver, lower layer to upper, right? So these are, so here you can see generally this is control plane. And right, as I said, construction of road is a complex process. Once road is constructed, vehicles moves without any issue. Am I correct or not?
Yeah. 1 minute, one small doubt, Bella.
Go
So
ahead.
here, like that here, yeah, in this diagram, what you show here. So it's a user plane or it's a
It's control plane. This is
yeah.
control.
Okay. So in this control plane, you are telling that TX sides that communication moves from higher layer to lower layer. Okay. Then the same thing, lower layer to higher layer in the receiver end. Okay.
Correct.
But
This applies for both user plane and go ahead.
okay, so my doubt here is, but the second plot general thing is protocol to protocol connectivity. No, the layer to layer connectivity. You are showing that arrow mark physical
This
to
is
physical layer.
message understanding. Means transmission and read happens at the same level. Okay.
Hmm.
See, two companies are there, I'll tell you. Simple language.
Okay.
Okay. Company A is there, company B is there. Okay.
Hmm.
Company CEO will be there here, company CEO will be there. Okay.
Hmm.
Or
Okay.
director. Okay.
Okay.
Manager. So even you can say, uh, right, engineer. Okay.
Okay.
Right. So if he explain, right, these two engineers, right, working on some project, they only know what is what. Okay.
Hmm.
If this engineer reported to this director, how we can understand?
Not understand.
Not
Yeah.
understand, right?
Exactly.
In the
Yes.
same company, accountant is there. Okay. Okay, accountant is there. Then some TA means like a HR kind of thing, talent acquisition team.
Okay.
Okay. Right, generally these people, right, if this TA people wanted to interact with the engineer or manager,
Mhm.
right, for what level? Only what these people, generally these people shares the resume. Okay, these people will say yes or no, suitable or no. Okay,
Yes.
otherwise if these people are explaining, right, so this is the LTA and all, will these people understand?
No. Yeah.
Technical. So level definitely. So what am I saying? If my Same thing here happens. If my physical layer directly transmitted message to MAC layer cannot understand what is this. That's
Okay.
what I am saying. So if RRC sends or RRC sends something directly here, nothing. So this communication, what am I saying? It is not a physical communication. It is a virtual or understanding level. That's why message understanding level. Always physical transmission happens through physical layer. Right here, it will be my bandwidth. Okay. So for example, this is my bandwidth. Let us say it's a grid. Okay. So message is moved. Are we recording this?
Somebody recording.
Oh, okay. So simple, our logic is very simple. So for example, this layer RRC, right, sending a message, right, definitely that has to go through. RRC cannot directly transmit. RRC has to transmit. My physical layer can only transmit this onto somewhere in the bandwidth, where this bandwidth is, right, comprises of resource blocks, right? So for example, if this message, right, occupies 10 RBs, let us just example, right, 10 RBs, right, somewhere this 10 RBs will be assigned and this bandwidth is, right, transmitted into the space. Right here my mobile, right, whenever it gets this bandwidth, then it starts reading its data, right? Sometimes this mobile may get data, may not get data. Got my point?
Yeah.
So now somewhere data here, now my mobile, right, once it gets the, generally you can say subframe, okay? Subframe of bandwidth, some bandwidth maybe 5 megahertz or 10 megahertz or something, okay? Let's take. So once this UE received a subframe, it starts searching its data, right? Is my data there? Here, no, here, no, here, no, here, no, yes, here, yes. Right now it starts reading. So when it is reading, definitely, right, definitely it cannot understand what it is, right? Then it will give it to respective layer. Means its job is, right, just pushing, receiving data and pushing it to other layer,
Excellent.
other layer,
Excellent.
other layer, other layer. Now when it comes here, this, yes, this, yeah, yeah, I can read it. It can read it. Okay, it can read it. If some message constructed at this level, MAC, right? For example, one message has sent by this MAC. Again, MAC has to send it to physical layer, then physical layer has to transmit. Let us take next time. Let us take next time. MAC layer is sending data. So somewhere here, MAC layer. Again, it is reading. Yes, my physical layer is reading. It is sending to MAC layer. Yes, my Mac said, oh, this is my message only. I can read it. Got my point?
Yeah, yeah.
Clear?
Yeah, clear, clear.
So in generally, if I compare, there is a OSI ISO layer, or you can say the 7-layer model or five-layer model. If I say still, generally, always, let me say, this is my mobile. Okay. Let me go through from the application layer. Okay. From application layer point of view. Okay. So here it is my mobile. This is my base station. Okay. Right. So somewhere my friend mobile is here. My friend mobile, right, wanted to send some data. He is sending his photo to me. Let us just consider. Okay. Right. So always, right? If I consider OSI, right? Definitely each and every data communication, each and every data communication, right, will support, right, will support with the OSI. Okay, CSR, PS, you can say. Okay, definitely, if I take, uh, so here there will be an application layer. For his also, there is an application layer. right? He might be taken a photograph, which is a photograph which comes under the application layer. Okay, this is application layer. Okay, application layer can only visualize the photo or PDF or Word, whatever it is. Okay, this will be sent to, right, session layer. Okay, presentation layer. Okay, transport layer, network layer. Okay, means each of these have their own. Now here our mobile means here our LTE or 5G stack fits. Right, in generally network layer, right, data link layer, physical layer. Okay, means application layer still on top of our protocol testers, there will be a network testers.
But here, how do we correlate the protocol stack, what we explained before, and here this OSA reference model? This
That's what I am putting, right? So LTE or 5G or 2G or 3G or 2G, right? Wi-Fi, okay, or Bluetooth, whatever you take, all will fit into these two only.
okay,
Two
two
layers.
things. Yeah, two layers, including from RRC to physical.
Correct. If I expand these two layers, now our mobile stack will come into picture like this. Okay.
Okay.
Whatever we are calling about, right? Maybe you can say it is a user plane or data plane, right? If data plane comes, right, always data comes from the network layer. Generally, we say IP packet. Okay. Got my point.
Yeah.
Right. So let me take right. So here, let me take user plane. Okay. I'll take uh, control plane in a moment. Okay.
So in the data on physical, actually, we are segregating data on physical like two layers for the different protocol stack from
Correct.
RRC to PDCP.
Correct.
But here, that only the broad two broad things are there, data and all the seven things is included, which is data, which is physical, like segregation, anything is there?
No, no. So only right entire whatever we are discussing, let us take PDCP. Okay. RLC. Okay. MAC. Okay. Then physical layer. These four layers fit into this. If it is user plane stack, right? What is the control plane stack? Right? Control plane stack, right? So comes with the NAS, okay, RRC, which are separate, means which are you can say same again, PDCP, RLC, MAC, physical layer, right? Okay. So for example, if we wanted to send photo is a data, right? Always. Got my point.
Yeah.
Photo, that's what I've taken photo to make you understand. Photo is a data, definitely. Right? I can visualize in my friend is able to visualize his photo in his phone and he wanted to send it to me. Then he just clicked right send button. So how this photo is transforming? This photo goes to presentation layer, sorry, session layer, presentation layer, transport layer. For example, this is right. This photo is of, let us take 100 MB. Of course, it will not be, but let us consider 100 MB. 100 MB cannot directly push, right? So it will be right divided into some number of packets. These packets will be sent. Correct or not?
Yes.
So my friend is in US. Okay, my friend is in US. So whatever the packets, right, delivered packet number one, packet number two, right, this 100 MB is divided into 1, 2, 3, 4. Now networking, this layer, what this layer do? It deals with the IP, right? My friend is in US, I am in Hyderabad, he wanted to send. Definitely IP address is required and routing in the network is required. Correct or not? I don't know whether data is coming directly from the US or data is going to enter into European countries, and from European countries it traveling all the way to India. From India, maybe it is entering either sorry, Mumbai, or it may be entering into Vizag, but I am in Hyderabad. Somewhere it is entering into India. Am I correct or not? Through sea. So definitely this network layer helps in the routing. Okay. So now when it comes, right, the packet will enter into data link layer. So which, right, means I can say data, user plane data always enters into PDCP from the application layer. So sometimes I used to write straight away from application layer to, right, PDCP entry. Got my point?
Yeah.
So sometimes, right, I take all these layers as a application, right? Instead of writing every time all layers, right? I'll write application layer. Data generates from application layer, right? Of course, it has to travel like this, like this, like this, right? Like this. Then it enter into the data, where our stack takes the packet. Okay, but still everything there in inside your phone. Okay, for example, if issue, right, for example, when I am doing a throughput testing, okay, so the packet construction is not good, or right, we say nothing, there is no issue from the our protocol stack or LTE or 5G stack. There is a packet, miss, you can say IP packet is very smaller. It is not building a big packet. Then network people will take care of it. Got my point? They will take care of it. Means networking point of view. Right. Now, for example, if there is any, right, here it is control stack, right? Control stack. So now always messages may be generated at here. Okay. Two things, message may be generated here, okay, that will be forwarded to RRC, or sometimes messages may be generated here, that will be posted here. Got my point? Okay. So because these are control messages, NAS message, RRC, both are CP plane messages.
So could you please explain about NAS, non-access datum? That's a little bit explain more about the NAS messages, because I come across the word.
We will see that. This is just follow me.
Okay,
We
okay.
discuss, see, our entire 3 months, 3.5 months, we discuss those things only. No need to
Okay.
worry. Just explaining how communication moves,
Okay.
how things are happens inside the mobile application. Okay. So now see, data is generated here. Okay. Pushed through other layers, entered into PDCP. Okay. Data, but if it is not photo, it is not a photo, right? It may be, these are control plane messages, NAS, RRC, PDCP, for example. Sorry, NAS
So
and
it's
RRC.
one more. Sorry for the intervention, Nagendra. So
Hmm.
here initially, first thing is even app to and remaining thing it's going on directly. It goes to first control plane, then it comes to user plane. No.
No, see, both stacks are different, man.
Okay. Okay.
Different.
Yeah.
That's what
Yeah.
I am saying. This is
Mm-hmm.
one stack and this is another stack. Even though it is look like, of course, if I can write like this.
Okay.
So let
Yeah.
me show you exactly.
Different stack. Okay. Yeah. Different stack. My question is, that process is first done in the control plane only, no? Because it's signaling is.
Correct. Signaling always control plane. That's what I'm
Yeah,
saying.
yeah.
Explaining the difference. So you can see this is okay. This stack is there from P gateway to user. Okay, P gateway to user. Both UEs are not there. But you can say end to end. Okay, IP packet, then PDCP. That's what I'm saying. Huh? Application layer generates always the application, whether it may be not only photo PNG or it may be PDF file, it may be Word file or Excel file. We say it is an application. Okay, that enters into our protocol stack, right? As a user application. Then other layers, right? It goes like this, it goes like this, it goes like this. Clear?
Yeah, clear.
Right? Is anyone have any doubt here? So now, right, when data is right somewhere, my friend started, friend wanted to send his photo that travels like this, right? So after network layer, it enters into PDCP, RLC, MAC physical layer. From the physical layer, okay, from the physical layer, of course, this will be transmitted onto base station. Correct or not? So from my physical layer. Okay, from my physical layer, this data will be put into a bandwidth, right? Placed, right? The bandwidth, the data, photo data, right? I can say photo data maybe occupied 10 RBs, right? So this area, let us take this area, 10 RBs, right? So that photo is placed here, but photo in the form of bits here. Got my point? Bits. Now this is in PNG. Let us take JPG or PNG format. Correct or not? The format of photo is in PNG or JPG. But when data is before transmitting from mobile to base station, it will be in the form of bits. Clear? So now my base station takes it. Okay. Then it retransmit. So this base station is, you can say, sometimes a repeater, or you can say, right, just base station takes and retransmits. Same thing, right? This also uses some bandwidth here, right? The data might be transmitted somewhere here. Okay. Now this my mobile has picked up, right? So physical layer, MAC layer, okay, right? RLC, then PDCP. Now this PDCP data should goes to network layer, right? Correct or not? Network layer, then transport layer. I should see photo, right? Where I can see? In application layer only.
Okay.
Application layer can only present my friend photo in front of me. Otherwise, I cannot read it. Okay. Then presentation layer, then session layer. Finally, application layer. So this exactly what happens. All right. Presentation layer, session layer, application layer. Here only. Once my photo reaches, my friend photo reaches here, I can see this photo. Right, if it is corrupted anywhere before reaching, I cannot see my friend photo. Okay.
Okay.
Issue may be here. Okay. Issue may be here. Issue may be here. I cannot say exactly where is the issue. Right. So if issue is here, I will check as a 4G, 5G protocol tester. If issue is there here, network, this, they will check. Got my point? So means LTE level throughput will be checked. Network level, right, TCP, right here, TCP, UDP level throughput will also be checked. Right. If you are testing the throughput, it is not only It is not only LTE throughput, or you can say physical layer MAC, RLC, PDCP throughput. It also involves network IP packet, right, as well as a TCP UDP throughput, if you remember. Okay, means like communication always, right, somewhere started from application layer. Again, it has to reach to the application layer. Otherwise, right, I cannot see my friend's food. Clear?
Okay, sir.
Any
Okay.
doubts from this? So always on top of our protocol stack. Okay, always on our protocol stack. There is a, right, I am clearly writing. If I say this is my, it can be not only, I'm saying not only mobile, it can be Wi-Fi, it can be Mac, RLC, right, PDCB. Just I'm taking for application point of view, right, on top of this. Okay, you can see we have OSI is the reference model, but TCP IP model, right? TCP IP is using. So simply application layer. Okay.
Session presentation.
No session. TCP, UDP,
Okay, sir.
network. 5-layer model, right? If I extend this to 2 layers, right? So this becomes physical layer. This becomes a data link layer.
Okay, sir.
Got my point?
Yes.
5-layer model. This is 5-layer working model. OSI 7-layer model, it is a reference model. Every communication is taken from the reference model. Okay, if I go for, this is, you can take maybe 4G stack, 3G stack, 5G stack, all stacks you can say, 5G, 4G, 3G stack, right? If I go for same thing, WLAN or Bluetooth, right? Same thing here, application layer, okay, TCP, UDP, network layer, right? This data link layer, right? You can say there also, right? If I take WLAN, right? There also there is a physical layer, right? Then lower link layer, lower data link layer, and UL up means upper link layer, data link layer. Both layers are there. Okay. So these two, again, I can say this is usually Wi-Fi, but if I write in terms of TCP/IP, data link, and physical. Okay, means always, right? Always, right? Just erasing on our mobile stack. Always there will be a TCP IP stack. So that's why when you are testing the TCP, throughput, right? You will check here what is the throughput here, what is the throughput here, here. If I am not getting whatever I expected, then you should check what is this throughput, what is this throughput, and this throughput. We have to, right? Sometimes we have to observe these two throughputs also. If you don't see any issue, then we will give it to, right, network engineers. Then they will take care of the test. Clear? So these all three together, I always used to write application layer, write data enters into PDCP. I write like this. You remember? Okay. Clear?
Yes, sir.
Okay.
Go outside.
Yes, sir.
Right. So now we know, right? Just we have seen once again. Let me write two protocol stacks, UP and right. So here CP control plane, or else let us do control plane physical layer, MAC, RLC, PDCP, right? RRC and NAS. Guys, please mute your.
Okay.
Okay. So whereas user plane, okay, physical layer, MAC, RLC, PD, so PDC. That's it. Okay. Right. So this is user plane, right? Right. As I said, always we discuss CP plane only. UP plane, right? So this is a construction. Means like when you are when connection establishment is happening, right, between these two or among these three, right? So here CP plane comes into the picture. Here CP plane comes into the picture. Okay, here CP plane comes into the picture. Here CP plane is a NAS, right here NAS. Okay, control plane. Here also control plane. Here also control plane. So these two control plane stacks talks to each other means whatever the message sent by the NAS layer can only understand by the NAS layer of mobile, even though it is transmitted through base station cannot understand. Whenever it receives a NAS message, this is not for me, right? If you are giving a love letter to someone, right? Definitely there will be a name. You are in a classroom, right? You are sending a letter or love letter to your girlfriend. You given it to somebody in between. That they just see name and they will forward. They don't read it, right? Generally, if they know the language, if they may read, but here base station will jump, just simply looks the message. Oh, this is not my message. It will simply forward. Clear? Right. So
Yes.
definitely here RRC means whatever the message, right? Whatever the message can generate either here or here, means like control message just we have seen. User plane data will generate in the application layer. Straightforward, just I explained. Application layer to directly it comes to PDCP through all right TCP, UDP and network layer directly it will enter. That is user plane data. Control plane data will always generate either here or here or here or here. That's it. NAS message may be generated here and transmitted here, or NAS message may be generated here that will be transmitted here. Right? RRC message may be generated here or generated here. If it is generated here, it will be consumed here. If it is generated here, it will be consumed here. Got my point? Other end. If message is generated here, right, consumed here. If this message generated here, it will be consumed. Clear? Right?
Yes.
Okay. Then PDCP. Okay. RLC. Then MAC. Physical. Okay. RLC. MAC. Right. Physical. Got my point? Right? Definitely. Right? Some messages, right, starts from here. Some functionality starts here, which will be, right, for example, this will attach the integrity key, right? So this will consume the integrity key. Okay. So for example, this attaches the mode, here it will consume, right? For example, here it is generated some command, right? Mac seeing, this will be consumed here itself, right? Whatever the physical layer, right, that will be consumed. All need not to go to RRC. Whatever the physical layer message that we, here it is generated physical layer message, it will be consumed here only. It will not go RRC. Respective message goes to particular layer. That's what my dotted lines. Okay. If message or some data format is generated here, that will be consumed here, read here, right? So generated here, consumed. So that's why layer to layer communication, layer level communication, but always communication happens through physical layer. Got my point? So let us take, right here message is generated, bandwidth will be here. Okay, now this message will be pushed here, right? If required integrity and authentication will be added here, then pumped either through UM or AM. Then if it is required, right, MAC will process it, then it will be placed to physical layer, right? Physical layer converts, right, the complete data into bits. Simple example I'm saying, right? Then this data will be placed somewhere here, right? And this will be transmitted into the air. Right now my physical layer, right, when it received this, reads, right, this data, then if it is physical layer, right, here consume. If not, it will goes here. So right, so then we have taken message from RRC, right, from physical layer to data goes to MAC to RLC to PDCP to RRC. Right here it is consumed, read. Clear? So this will, this is a rule. This is what we say protocol, right? This we call protocol. You have to test the protocol. Is there any abnormalities in the protocol stack? Clear?
Yeah. Yes,
Right?
sir.
Even if it is generated here, that comes here. Okay, that comes here. This message will be encapsulated right inside the RRC message, right? Then that goes like this. Okay, just keep it in mind, right? We'll see further. Okay. If no doubts, we can close the class for now.
Okay. Thanks.
Okay. Thanks. Okay.